Hello everyone. In this video, we will discuss about what are carboranes, what is the structure and bonding of different carbonanes, how we can identify the structures of carborane by using weight rules, and what are the preparation and properties of carborane, and what are the different applications of carboranes. Now let's discuss what are the learning outcomes of present video. After studying this lecture, you will be able to know what are carbonanes. You will also understand the history of carbonanes, how they come into existence in the literature, and we can also explain the structure and bonding of different class of carbonane by using the weight rules, and from using weight rules we can calculate the different class of carbonanes. We will also discuss preparation and various reactions of carbonanes in this video, and finally we will discuss what are the different applications of carbonanes in different areas of chemistry. Now come to carbonanes, how we can define the carbonanes. In the previous lectures we have discussed about boranes, that boranes are the metal crystals which is mainly composed of boron and hydrogen. Similarly, carborane is a cluster compound which is also made up of boron, carbon, and hydrogen atoms. And the general formula of carbonanes is it is the C2BnHn plus 2, in which n is a integer value, where carbonanes we are having n, it is ranging from 3 to 10. That means if we are taking the value 3 to 10 in case of n, then we will get the different class of carbonanes which is found in the literature. And basically carbonates are also called as mixed hydrides of the boron and carbon. In this figure, we can see it is a ball and stick model of the carbonates, in which white color balls they represent the hydrogen atoms, while pink color balls they represent the number of boron atoms present in carbonates, while these black color balls they represent the number of carbon atoms present in case of carbonates. Like related to many boranes, these clusters are also polyhedrals, and similarly they can be classified as closo, nido, arachno, hypo type of class based on whether they represent a complete closo polyhedron or polyhedron that is missing one nido, two arachno or more vertices. And these are the different structures for ortho, meta, para carbonanes that we have shown here. Now let us discuss about history of carbonanes, how they come into existence in the literature. The first carbonanes were produced in 1950, but the results were not declassified and published until 1962 to 63. And since then, many thousands of carbonanes have been prepared, and they have been combined with the transition metals to yield derivatives that are called metallocarbanes, and some of which show catalytic type of activity. And carbonanes are also known as heteroboranes because boranes are the compounds which is mainly made up of boron and hydrogen atoms. When we are adding some other atoms like carbon in the boranes compound, so they are referred to as heteroboranes. That's why these are also referred in the category of heteroboranes. And the 1,2 chlorodicarbodo decacarboranes, usually simply called as carboranes, they were reported simultaneously by the group at Olein Corporation and the Reaction Motors Division of Thiokol Chemical Corporation working under the US Air Force, and it was published in first time in the 1963 in the literature. Now come to the structure and bonding of carbonanes. How we can identify the structures of different carbonanes and what type of bondings are present in case of carbonanes. In the slides we will discuss about that. The carbonanes are having polyhedral molecular structure which is based on the network of boron and carbon atoms, in which carbon atoms occupy the adjacent position in different structures. And carbonanes and their derivatives They are similar to those isoelectronic polyhedral boranes. Isoelectronic means they have same number of electrons in case of polyhedron boron molecules. So they are also similar to those which are isoelectronic to polyhedral boranes. Like the boranes, which are mainly composed of boron and hydrogen only, they involve three centered bond as well as two centered bond. That means they are having three centered two electron bond, in which we have discussed in the previous slide that one electron is from boron, that is of sp3, one electron from 1s of hydrogen, and one electron is from boron atom. Similarly, ordinary two electron bond means one electron is from boron and one electron is from one h orbital. So that forms the two center two electron, that is of ordinarily covalent type bond. Similarly, they also involves the three-centered two-electron bond and two-centered two-electron bond in case of carbonates also. And their most significant structural feature is the covalent bonding of carbon simultaneously to fix the 5 and 6 other atoms. The nomenclature of carbonanes employs the same structural prefix, like we have closo, we have nido, we have arachno, and so on, which we have used in case of boranes also. And the numbering of the atoms in carbonanes compound, it begins with the apex atoms of the lowest coordination, that is with the fewest bond, and the polyhedral vertex atoms are numbered in a clockwise direction, with the carbon atom which is given the lowest possible number in case of carbonanes. Now come to weight rules. Sometimes it is also called PSEPT, that is polyhedral skeleton electron pair theory. And in chemistry, polyhedral skeleton electron pair theory, it is given to count the electron numbers for prediction of shapes of clusters such as boranes and carbonanes, etc. And sometimes it is also called as weight rule या weight chemistry. For this, Kane Wade developed, that is the Kane Wade, developed a method for the prediction of shape of borane clusters. However, it may not be used only for boranes, that can also be utilized for some substituted boranes like carbonanes as well as other classes of different cluster compounds. And weight rules are also used to predict the shape of boron clusters by calculating the total number of skeleton electron pairs, that is SEP, which is available for cluster bondings in different clusters. And the general methodology which can be utilized for calculation of SEP, which is given by weight, that is, it can be as follows. First, determine the total number of valence electrons from the chemical formula. That is, we can take 3 electrons per boron atom and 1 electron per hydrogen atom. And the second, then subtract 2 electrons for each BH unit, or 3 electrons in case of CH if we are having carborane cluster. Similarly, divide the number of remaining electrons by 2 to get the total number of electron, that is SEP, skeleton electron pair. So after that, we can see what type of shape can be possible on the basis of available number of SEP electrons for that cluster. Suppose if we have a closure structure, that is formula is BnHn2 minus, if we are having skeleton electron pair, that is SEP is equal to n plus 1, then that cluster will be in the category of closo class. Similarly, if we have nido class, that is BnHn plus 4, if we are getting the value n plus 2 SEP, then that will come into the category of nido class. If we are having general formula BnHn plus 6 and we are getting the n plus 3 SEP electrons pair, then we can say that it comes under the class of arachno. If we are having general formula for clusters BnHn plus 8 and we are getting the number of electrons pair, that is SEP, n plus 4 after calculation, then it will come in the category of hypoclass. And at last, if we are getting n plus 5 sp electron pairs whose formula is BnHn plus 10, then it means that it comes under the class of clado clusters. So this is the how we can calculate the predict the shapes of different clusters like boranes and carboranes, etc. Let us take some more examples for calculation of number of SCP through which we can predict the shape of different clusters of either boranes or carboranes. For B5H9, we have already calculated in the previous slide. For that, we are getting the value of n plus 2. That means it comes under the class of nido cluster. Now let us take another example, that is B2S7 minus. In this case, we have, because we have two BH units and we have discussed that for each BH units we have to take 2. That's why we have 2 into 2 is equal to, we are getting the 4 number electron. Similarly, we have here remaining is the only 5 electron. So for 5 electron, 5 hydrogen, we have taken the 1 electron from one H atom. That's why we have taken 5 electron in this case. And its overall charge is minus 1. For 1 minus charge, we are taking the 1 electron. So total number of electrons, that is equal to the 10 electrons. That means it is equal to the 5 pairs, because we have in 1 electron pair, we have 2 electrons. That's why it is giving the 5 pairs. Now calculating by this one, we know that in this case we have number of boron atoms is equal to 2. That's why we have taken the n is equal to 2 value here. And when we will calculate with these electron pairs, then we will find out that remainder will be 3. That's why it belongs to n plus 3 category. That means it is the shape is of type arachnotype clusters for B2S7 minus. Let us take an example, which is the class of carboranes. Carboranes are the metal clusters which is made up of, along with the boron and hydrogen, they are also consist of carbon in molecule. Here we can say this is the formula for carborane, C2B10S12. So along with the boron and hydrogen, that also consists of carbon. So that's why they are referred to as carborane instead of borane. Now let us see how we can calculate. As in case of weight rules, we have discussed for each CH unit, we have to take 3 electrons. That's why we can say here 2 CH units are there. So for 2 CH, we have taken here 6 electrons, because 2 into 3 is equal to 6 electrons. Similarly, here we have 10 BH units. For each BH units, we have taken 2 value. That's why for 10 BH units, we have taken 20 electrons. Total number of electrons equal to 26. It means equal to the 13 pairs for 13 years, because we have 2 carbon atom and 10 boron atom. So n value is equal to number of carbon and boron in case of carbonate. That's why we have taken n is equal to 12 in this case. But when we will compare with the 13 pairs, we will find that 1 is remaining. That's why we are getting the value of n plus 1. N plus 1 is categorized for closo clusters. So we can say that C2B10S12, it comes under the category of closo type cluster. Similarly, if we are taking another example of carborane, that is C2B9H112 minus, for each CH unit, in this case we have 2 CH, that's why we are taking 2 CH equal to 6 electron. And we have here we have 9 BH units. For 9 BH units, we have taken 9 BH 9 into 2, that is given 18 electrons, and overall charge is 2 minus. For each charge we are taking 1 electron. That's why we are value is the 2 electron. So total electron 18 plus 6 plus 2, that equals to 26 electron. It means that is equal to 13 pairs of electron pair, that is SCP. For in this case, we have 2 carbon, 9 boron. So total number of value is equal to n is equal to 11 we are putting here. And when we are comparing with electron pairs, 2 is remaining. That's why we are having n plus 2 value for this type of cluster. So we can say that this type of cluster, it comes under the category of nido class. Similarly, we have calculated for different types of substituted and different class of clusters for using weight rules. In which class they are categorized, like this one is under category of closo, this one is for closo, this one is also closo. That comes as B9H11 comes in the category of nido clusters. Now come to the synthesis of carbonates, how we can synthesize the carbonates molecules. Carbonates are generally prepared by the reaction of acetylene, or we can say acetylene derivatives with boron hydrides. And when we are reacting the acetylene molecules with the boron hydrides, then we will get the carbonates class. The three isomeric icosahedral chlorocarbonanes, that is ortho, para, and metacarbonanes, whose formula is C2B10S12, which are having unusual both in their ease of preparation and their stability in air. They can be prepared. The most common carbonate, that is the orthoisomer, it can be prepared by the reaction of acetylene with decaborane 14 in presence of a Lewis base such as diethyl sulfide. As we can say in this one, it is the most common class. We have taken here nidoboranes hydrides. Then when it is reacting with the diethyl sulfide molecule, then hydrogen molecule is removing from that one. After that, it is converting in the form of arachnotype clusters, and when again further on treatment with the acetylene molecules, then we are getting the one of the common carbonate, that is clozo 1,2 C2B10S12, that is the ortho isomer of carbonate, which is one of the most common carbonate known in the literature. As we can see in this case, these are the reactions through which we are getting the orthoisomers of carbonate in this one. In this slide, we will discuss about some reaction which can be given by different carbonate molecules. Carbonates could be degraded to nidocarbonates anions by the reaction with strong bases like sodium ethoxide in protonic solvents like we have taken here, those which is capable of donating H plus ion in solution. As we can see in this section that clozo 1,2 C2B10S12, it is reacting with the RONA, that is sodium ethoxide, in some protonic solvents that we have taken here, example alcohol, then it is converting in the form of sodium nitro 78C2B9S12 plus boron ethoxides. Plus, it is giving some molecules of hydrogen where R can be an alkyl group. Another reaction, these nidoanionic cages, these are called as dicarbonate anions, which is from Spanish ola word, which means bowl, lead to the preparation of metallocarbonates with their extensive chemistry. Another reaction, then, when it can be prepared, that when acetylene is reacting with the decaborane in presence of Lewis base, so we are getting orthocarborane, and unlike boranes, they are highly stable in nature at, that is thermally stable at around 400 to 500 degrees centigrade in an inert atmosphere. They are converting in the form of metacarborane, and further on treatment 600 to 700 degrees centigrade, metacarbonanes can also be converted in the kind of paracarbonanes. Now let us discuss some of the applications of carbonates which are mainly found in case of different literatures available on the internet sources. We can here discuss some of the applications like, as we can see that C2B10S12, that is also known as orthocorvine derivative, it has been considered for a wide range of applications from heat resistant polymers to medical applications. That means that carbonates can be utilized for medical purpose in different areas. Secondly, carbonates can be utilized as a unique framework in drug design. Due to its unique and chemical properties, they can be a potential material in drug delivery system. So we can also utilize as a unique framework in drug design system in case of medical field. Carbonates have also been used to make solids like superacids, Superacids are the substance which is having more than 100% acidity purity than that of sulfuric acid which is of 100% pure. And in coordination chemistry, carbonanes can also be used as a unique bulky ligands, scaffolds. Carbonanes can also be used as a tool to tune phosphorescence, and they can give the different phosphorescence on putting in the solution. Carbonanes have potential applications in BNCT, that is the boron neutrino covalent therapy function, materials, and supramolecular chemistry. Because in BNCT, they have boron 10 atoms that can be selected, targeted on the targeted tissues through which they can be very beneficial in case of drug delivery systems. Now let us discuss what is the summary of the present video. After completion of this lecture, we can explain that what are carbonanes, and we also know the history of carbonanes, how they come into existence, who discovered the carbonanes, what is the structure and bonding of different carbonanes, how we can calculate the structure of carbonanes by using weight rules, what is the preparation methods and various types of reactions that is given by carbonanes, and what are the different applications of carbonanes in different areas that we have discussed in the present video. On the basis of present video, these are some of the practice questions that you can easily solve by watching this video. The first is we can define what are carbonanes. As we know that carbonanes are the metallic esters which is mainly composed of boron, hydrogen, along with the carbon that is called as carbonyl. Second question is that we can calculate the structure and bonding of C2B10S12. Yeah, we can take some other example by using weight rules. Write the preparation and reactions of carbonanes that we can also discuss. List the various applications of carbonanes in different areas. So these are some of the practice questions that can be easily solved by using this video. These are the references. Thank you for watching this video.